I just want to kind of make a supporting video to kind of go over this. I know that the requirements were to kind of create the PDF, but I made the PDF and I just maybe want to talk a little bit more about it. So just kind of going over the document itself and what we're trying to do here. So the main request there was to kind of create a DynamoDB based data model for a wrestling tournament management system. So this would be for managing a large number of schools that have wrestling tournaments, and then how you're going to manage all these matches coming in with the data that they'll be having, keeping it as efficient and as scalable as possible. So one of the main things that we have to kind of keep in mind with the DynamoDB model is that the data has to be set up in a way that joins are not required. So we'll aim to use denormalized data and design our keys with access patterns in mind when we're actually building the data out. Okay, so let's think about the actual requirements here. So the requirements based are to kind of make these three access patterns work the best. So I've actually added one extra in here so that we get a use case for a GSI, because I think the others will kind of get covered with entities themselves. So the first one is to retrieve all wrestlers participating in a specific tournament by weight class. The second one is to retrieve all matches for a specific wrestler across tournaments. The third is to get a wrestler's win-loss record against opponents in their weight class. So in this case, I've kind of taken it in a very specific direction. So I've thought about the way that I would do this. And the question is a little bit ambiguous. So I've kind of gone with the win-loss record against a certain opponent versus being against any opponent in their weight class. If you're going with any opponent in their weight class, then it'll probably be a little bit different, but the design that I've kind of built here is for there being versus a specific opponent in their weight class. And then we have a GSI case, which is that you want to get matches played by a wrestler within a certain timeline. It's to kind of add a time dimension to the data itself. And so the system needs to be scaled, needs to allow for scaling, and it needs to allow for there to be a high throughput operation. And again, we've kind of spoken about the system constraints. There's going to be a single write coming in, and we have to use that to then build the rest of our system out. And again, a top level discussion about what the entity is here. So in this case, we have a wrestler, and the wrestler is the core entity for the student that's actually doing the wrestling. So they will have attributes like name, school, grade, weight class, history. That's kind of added in. I haven't put that in this attribute set, but then that's something that's extensible. And then we have a tournament. A tournament is the actual event in which all of these matches are occurring. We have a registration, and the registration itself is how we tie a wrestler to a tournament and to a specific weight class. So it's a many-to-many mapping between wrestlers, tournaments scoped by weight class, because the weight class might change. But then this is going to be very specifically tied to a weight class. A match is the actual entity when the wrestlers fight each other, and then it'll have an outcome. And then we have the head-to-head summary. The head-to-head summary talks specifically about the win-loss record against a specific opponent. So that's kind of how this has been built out. Again, this part is the one that I feel can go a few different ways, but the one that I've picked here is versus a certain opponent. So I have a discussion here about the attributes that we have for each of these different entities. So a wrestler will have a wrestler ID. Again, information that I think is pretty straightforward here. The only thing I kind of talk about here specifically is that the way that I've built the wrestler 1 and wrestler 2, we'll speak about it a little bit later, but I want this to be a single record. I don't want there to be two records, because otherwise we'll kind of go off into a case where every wrestler would need to have a win-loss record against every other wrestler. So that will have too much data. So we'll think about a way to keep the data efficient as well as keeping the data correct. Okay, so these entities are obviously not really going to be tables because it's a DynamoDB setup, but we will denormalize all of this into a single table structure. And we will make sure to kind of get the access patterns out as well as possible. Okay, so this is the actual design proposal. So we'll be going for a single table structure. There's going to be one single table that's going to be holding all this data, and we will separate out the different entities based on their partition keys. So and again, like, yeah, we'll have sort keys for them to kind of figure out how we will be serving that particular query based on the access pattern. So the aim here is to kind of go for a single query getting you all the data that you need without there being any joins required. So we'll first kind of go in from how we're doing the ingestion, and then we can maybe talk about the data model. I think it makes sense this way, to kind of understand why I've gone for a certain design. So the match is going to be coming in via an API, and the match does not have any other information on it except for the match ID, the tournament ID, and then like win loss and maybe other information about what happened in that specific match. So how do we actually build the rest of the data that we have going down? So the first thing that we do, we'll be basically creating up to four different records for every write that happens. So since this is going to be a read optimized system, we need to make sure to make all of these kind of decisions happen beforehand. So match items under each wrestler's partition. So I'm adding a match under each wrestler because we want to be able to get the matches that a wrestler has played in a tournament by weight class. So since it's going to be scoped by wrestler, we need there to be a separate match record for every wrestler that was participating in that particular match. So two records are created, one per wrestler, to enable fast access to a wrestler's match history across tournaments. And this is actually exactly going after AP2. And we will have a separate GSI that we were talking about, where we will also maybe add a time element to it. We can also have a optional match item under the tournament partition. This is not specifically required by the access patterns, but this will enable us to see all the matches played in a tournament without having to then go back and look at the players themselves. So this is maybe something that we can add, and I have done so for this use case. And then the third piece that's going to be happening when a write comes in is that we'll be updating the head-to-head stats item. So the head-to-head stats item is the one that's going to be giving you the win-loss record with one player against another. And the way that we are setting this up to make one single record for both is that we sort the wrestler IDs before we actually check. So if we have a wrestler, say 1, 2, 3, and then we have a wrestler 4, 5, 6, so the function will kind of sort 1, 2, 3, and 4, 5, 6 into a low and a high, and then do the PK check. So any updates that are going to happen to a match where 1, 2, 3, and 4, 5, 6 play, the update record is going to be the same. So it'll be we'll have like the lower ID wins and then higher ID wins. So higher ID wins and losses. So it'll give us one single record where we can deduce both the answers from one value, and it'll reduce the amount of duplication of data basically. So we would use DynamoDB transactions to do this, because then we can kind of use a separate system to measure how we would do error recovery. But we'll get to that one a little later. But yeah, so this is how the ingestion strategy would work out. And then I have the basis for the core model itself. So we have a wrestler with the PK being the wrestler ID itself, and the SK being the profile, as in we just write in the profile there as the SK. And again, the reason for that is that we are partitioning per the wrestler, so we can store all that information in one place. I think it makes sense. And then we have a tournament. The tournament partition key will be tournament ID, and then we'll have metadata as the sort key. So in this case, again, we have specific information related to the tournament here, so any pulls can happen off of this data. And then here we have the registration item itself. So the registration item has a tournament ID and a weight class attached to it. So it segregates the tournament into a tournament and its weight class, and then we add a wrestler there as the sort key. So it allows you to have a good split, because whatever we are hitting, any new registration that will be coming in will probably be coming into the same partition, so we'll not have to worry about going across different partitions to get the same values. And then we have the match So this is again, it's going to be per wrestler. We'll have a match per wrestler. So whenever a match comes in, we'll be getting 2 match records. So this collocates all of the wrestler matches, and it allows you to have a query that will give you every single match that a wrestler has played. So and also if the match IDs are created monotonically, then we can even use this to sort. We might not need the specific the GSI that we'll be coming to, but this will allow us to have somewhat of a sorting also with the match ID. And then we have the match per tournament, again similar, but with just the match outcomes here. So we'll have like wrestler 1, wrestler 2, and then as in whoever won, like the winner ID, and then win type and stuff like that. So that'll come into the match itself. And then we have the head-to-head stats here again. So it's sorted W1 and sorted W2 because that's the 2 wrestlers that'll be playing. And then the weight class in which this particular fight happened. And then you'll have stats. So this allows you to have a single like an O of 1 lookup basically for you to find any of these values. You don't have to do any calculations or aggregations later. And then this is the GSI I was talking about. So we will use a match chrono index. It's just a name. It doesn't have to look like that specifically. But so this would be a wrestler ID along with a date. So we would need to know that we're checking for date with the date and then the tournament ID and then the match ID. It's kind of similar, but it will allow you to find, say, what matches did this guy play from this date to this date can be done with this global secondary index. So I've kind of added exactly kind of the considerations that went into this. So one was that we denormalize the data, obviously, because it's not going to allow us to do any kind of join. So we have to denormalize. So we denormalize everything. We then also use composite sort keys. So we add multiple items into the sort key itself so that we are sorting based on the importance of that item all the way down. And with the right context, we can get exactly what we want. So we can just use one sort key, which is composite, to get multiple types of slicing. We aggregate, again, I think we spoke about the H2H part, and also the GS1 being used for a match specific timeline. We can add any extra GSIs. In this case, for the access patterns that were required, we didn't really find a need to add any of those. And I've added some extra information here about what partition strategy we were using, but I think it's pretty straightforward. Like since we have picked partition keys that can scale independently, they will allow for there to be a multiple, like a very large number of these things coming in. Should not cause any issues. So we'll speak about the issues that we can face a little bit further, which is I think about hot partitions and stuff. We'll have to think about how we would do that. I think so we can talk about that a little bit later. So one of the things is for the system constraint itself, how do we make sure that when a record comes in, we are only doing the processing once. So we can use a few different ways for that. One is that we have a unique match identifier, which I think is going to be the case anyway. So we would have a single match identifier for one match only gets one identifier. So it's globally unique. We have a monotonically increasing match ID setup. And the secondary one that we can think about also, which is pretty important, is that we have a conditional write that is going to be kind of locking an item potency. So we are checking for whether this match has already been processed or not. We can maybe have some kind of Redis set up there to kind of check against, or we can even just check in this case using DynamoDB itself. So we can check if that value has already been inserted, and if it's not, only then do the actual insert operations later down the line. So the head-to-head updates are done transactionally in this case, just so that whenever we have to, if any of these updates do fail, we can just add them into a retry queue or a DL queue and get them working somehow, so that we will have an eventual right answer over time. And the other idea here is to also have timestamping and versioning for every one of these data items that we're putting in, just so that we can maybe check against the version ID or the updated ID. So we can check if there is one record that is newer than the other one, and then that will become the main record and overwrite the others. Okay, so we're just talking about the actual queries here for these different access patterns. So the first access pattern that was required is to kind of figure out all of the wrestlers that are participating in a certain tournament. So I'm just calling that tournament brackets. So this is this code that you would write if you're using Python for this specifically. So you would be calling DynamoDB with the query value, and you're checking for PK here. We are checking for all the wrestlers in tournament T798 with the weight class 132. So in this case, you will have the PK being tournament, the tournament and the weight class that you want, and then the SK here, the sort keys all the wrestlers that are in that. So this is basically like searching for the registration table. You're looking through the registration table, and you're trying to get the all of the values with the PK here. So that is the tournament that you want and the weight class that you want. So this will be a single query to give you all of these wrestlers. And then the second one is to get all the matches for a specific wrestler in all tournaments. This is pretty straightforward too. So you'll be querying the match table equivalent. So you are doing just a wrestler. So this is for wrestler 1, 2, 3. So wrestler 1, 2, 3 sort by all the matches. And if the matches are monotonically kind of set up, the sort response itself will already be sorted by chronology. And then we have the third one here, which is to get the actual head-to-head record, which is pretty straightforward too. You do a initial sort on the wrestlers, so 1, 2, 3 and 1, 2, 7. You know that 1, 2, 3 comes before 1, 2, 7. So then you do the search for H to H with 1, 2, 3 and then 1, 2, 7, and then the actual weight class that you're checking against. And then the fourth piece here is again the chronologically sorted matches for the wrestlers. So this is where you'll be using the GSI itself. So to use the GSI again, so this response will probably give you a chronologically sorted list of these matches, but this will give you a date specifically. If you want there to be a specific date that you're checking against, you can use this GSI. And also here we have the scan forward index setup just so that it will specifically give us the ascending order that you would like to look for. Okay, so now that we've spoken about these patterns, we can maybe think a little bit more about exactly what design considerations we will have to go into to make the system work as a whole. So one of the larger trade-offs that we are kind of doing here is to very heavily do a read-heavy optimization. So that by its very nature will create a very heavy write load. So the initial, whenever a read comes in, we are generating 4 records. So there might be 4 to 5 records per wrestler per tournament, and in head-to-head stats being created. So there would be a increased write cost, but I think the number of matches that are getting played will probably be a lot less, and the number of people who are checking these values. So our system should be able to kind of work through the updates pretty well. The other piece is again, because we are doing again, it's pretty heavily write heavy in terms of the load on the system itself. We are also doing the pre-computed head-to-head stats, so we're just incrementing that win-loss record item for every one of these matches that are getting played. So we just need to make sure that we are keeping consistency in that data, and that will be a little bit more of an overhead, but it allows you to have much cleaner data in the end. So again, match duplication here we have to do because we are trying to get the data per wrestler per match. So yeah, it's most of these are mainly about how we have to think about there being more records being created for every one of the writes that are happening. We are using versioning strategies and idempotency rules here to make sure that whatever actually comes in, again, it is adding an overhead there because you're checking your database every single time a match comes in to see if the match has already been processed or not. But it does allow for a more stable and resilient system that does not recompute the same match twice. So this basically allows us to have a very lean, as lean as possible, with arguably a little bit more data than would be done with another kind of system. But this will allow you to have a very fast access patterns, and that's what you want. Okay, so then let's talk about the actual operational strategies of how we would maintain this database in production. So one of the largest pieces here is making sure that the matches get processed correctly. So we need to make sure that whenever these matches come in, since we're creating these 4 to 5 records, we need them all to be correctly set up, and any of these downstream issues that happen need to be caught and need to only be retried once, and all of those things need to be happening at in a way that we're considering any of the downstream impacts. So one of the things that we spoke about a little bit earlier, and we'll also have to do now, is that we would, if there's any failures in the ingestion, we need to make sure that is retried with exponential backoff. I think to make sure that there isn't any system problem that is kind of getting clogged in the middle somewhere. And if they all fail, then they go into a DLQ, and we need to have some kind of monitoring on that DLQ to make sure that we understand what happened with this particular record, and maybe we have a backup pattern to where we can go in and increase the value ourselves, maybe just to make sure that the data is correct. So one extension that can be added here is to actually close off a tournament. So in the setup that we have right now, there isn't really any clean way to know when the tournament is completed or done. But then we also have a start and an end date. So if it's beyond the end date, you kind of already know that the tournament is completed, and we can have maybe a winner ID and a winning school ID or something on the tournament itself. So now the tournament is by itself an updated record when these things get done. In this requirement that was given to us, there wasn't a tournament getting closed requirement, but that will be an extra record coming in. I would think once it's done. One of the larger pieces here that I think we have to think about is the hot partition piece. So when there is a large tournament happening, there's going to be a lot of matches being played and being decided on the same tournament partition. So this might cost us a little bit of trouble because we'd be hitting the same partition over and over again. So one of the ways to actually sort that out is for us to use partition key suffixing, and we basically split the partition for the tournament and the weight class again by a number that we can pick. So if we want this to be like maybe a 3 or 4 kind of split, we would just find a mod by that number, and then for the wrestler itself, or for the tournament itself, and then put that into a partition, into the partition name. And when we do the PK get, when we are trying to create the match record itself, we would slot it into its right partition. So this would allow us to have a lot of data going in, but then they're all hitting different partitions, so they're not really creating one partition that is getting extremely heavily write affected. But then the read is going to be the same anyway, so it doesn't matter too much. So we would have CloudWatch or any other monitoring software looking at the CPU loads for any of these things happening. So any of the overheads for the write that's happening, you go in and check, and you make sure that auto scaling is set up. You have the scaling set to where if any of these loads are getting a little bit too much, we can even maybe auto partition or maybe add an extra partition as and when required onto our database to allow it to be more extensible for a specific use case. Like if you don't expect this to happen, but then it does happen over time. And then a third piece here is to have an archival strategy. So you do not need all of this to be in DynamoDB over a very long period. So maybe the older matches can be offloaded onto a different backend system. So in this case, I've written S3, but we can use other ones also. We can have a TTL basically because it's a key value pair database. We can have a TTL there to where after if it's been more than a certain amount of time, we then offload onto a different system, and then we can maybe have a different strategy for how we do the tournament maybe history or match history. We need to kind of think about how we would pull all of this stuff together, but then that is not that's beyond the scope of this particular project. So again, just to maybe kind of tie everything together, there's a capacity planning section here just to talk about what the peak loads might be, and then how we think we might be able to work through these things. I think we've covered most of this up here, so I don't really specifically want to talk through this too much. But the system that we have right now will be able to handle all of the expected load patterns as well as any kind of spikes. So this is a little bit more about the actual DLQ strategy and error handling. How would we deal with that, and then how do we actually want to make that work? So DLQs here we'll be using only once the exponential back-off retries fail. So you have basically like up to three errors, and then if that fails, you put that into a DLQ and you put it into and once something goes into the DLQ, we alert. Maybe put like a Slack message somewhere using CloudWatch or Datadog or anything else that you would use. We would need to kind of think about how we would pre-process those DLQ messages. So that can be again based on how the operational kind of setup works for this. If it needs to be done immediately, it can be pushed off maybe manually, or we can have so in this case I've kind of gone through an idea here where we can use a batched Lambda job that will kind of go into the DLQ, pull all those values out once we make sure that it's all clean and everything, and then runs them again. So it runs them as like new transactions. That's kind of how we would work through this problem when there's kind of a failure. And yeah, and then like to conclude this, again, the system that I built is mainly prioritizing this real-time tournament responsiveness and making sure that the reads are as efficient as possible. So data duplication will happen in this model, and I would consider that to be acceptable because we want these access patterns to be as fast as possible. And with both of those constraints, this model is very scalable, and it minimizes the amount of runtime requirements for reads. And even if you want to extend this to having live analytics and everything kind of going onwards, it will also help doing that, because that will also be like a very read heavy operation in analytics, in my opinion. Okay. I have an appendix here that kind of goes through all the different sample data. It's just sample data to kind of maybe wrap your mind around what I've been talking about with all the different matches and how they would look. Yeah, okay. Thank you guys for listening to this. And yeah, I hope to hear back. Thank you.